Now guys, let's see how to do mathematical operations on matrices, because we all know if in matrices we can add a particular number to every elements, and then we can add or subtract two or more matrices, and similarly we can multiply matrices. So if you don't know how to multiply matrices, that is kind of tricky, so you should learn that first, because we cannot multiply all the matrices with each other. We should multiply like a 4 by 1 matrix with 1 by 4 matrix. That's kind of rule, and that's tricky. Before that, let me just declare one more variable, that is assume x, and that contains np dot array, and then here 1 comma 2 comma 3 comma 4. And now if I print x, it will be a 1D matrix with 1 row and 4 column. And yeah, if I just add x plus 4, you can see now 4 is added with every element of the matrix x. Similarly, we can subtract a particular number, for example x minus 3. Now yeah, and then x multiplied with 2 and x divided with 3. Now it is you can see 3 is divided with every element of that x matrix, 1 2 3 and 4. So you can also use like this, x plus equals to 2, and okay, we have to print it. So print x plus equals to 2. Okay, we have to print it after this line. So now if I just run x, yeah, now you can see it is showing the similar thing as 5 6 7 8 and 5 6 7 8. Yeah, so you can also use x plus equals to 2, and you can obviously multiply or square a particular matrix, for example x square, and it will be 25 36 14 and 64. That's perfect. So now let's see how to multiply two matrices, or how to add two matrices. For example, here is y, and that contain, for example, np dot arrange. Assume we want a 3 by 4 matrix, so there will be a 12 element, so we will write 12, then dot reshape, and then 3 comma 4. We want 3 rows 4 column, and that should look like this. Print a y. Okay, yeah, again a mistake, there is one single r. Yeah, so this is a 3 by 4 matrix. Now let's write a 4 by 3 matrix. So I'll just write over here y1, and that will be 4 by 3. So I'll just rename it 4 comma 3, and y1, print y1. Yeah, now you can see this is a 4 comma 3 matrix. So we can obviously multiply these two matrices, because this is 3 by 4 and 4 by 3 matrix can be multiplied. So y multiply with y1. Okay, well, it is showing this kind of broadcasting error. That is because if you go into the documentation of Numpy, you can see that this broadcast rule is actually if they are equal shape. Okay, so because we have differences, like different shapes, 3 by 4 and 4 by 3, that's why it is showing broadcasting error. In that case, you need to multiply like this, np dot, then the variable name, then the matrix name, okay, y and y1. So let me just save it into y2, and that will be equals to np dot then again dot, and in the parenthesis we have to write the first matrix, that is y, and then the second matrix, that is y1. Okay, so now if I just print y2, you can see now the multiplication has been done. So it is at now 3 by 3 matrix. Quite great. And similarly, if you just let me just print x again, so that you can understand properly. Print x. Yeah, so if we just wanna add another matrix, for example x2, and that is equals to np dot array, and that can contain like 7 comma 6 comma 5 comma 4. Yeah, so now if I just write x plus x2, and that will be, yeah, 12 12 12 12. 7 plus 5 is 12, 6 plus 6 12, 7 plus 5 12, 8 plus 4 is 12. Yeah, great. So we can obviously add, subtract, multiply multiple matrices, and that's quite fine. Similarly, we can also make a sign matrix or cos matrix, like a sine 0, then sine 30, then sine 45, sine 60, and sine 90. So for that, we just need to write np dot sine, and then the angle of the sine values. For example, if we pass this x, in that case it will make a matrix of like one row, four columns obviously, and the values will be like sine 5, sine 6, sine 7, sine 8. So let me pass it x, and then it will print sine 5, sine 6, sine 7, and sine 8. Okay, similarly we can obviously make cos as well. So sine, cos, tan, we can do that. This is the values of cos 5, cos 6, cos 7, and cos 8. Now, if you want to get the determinant of a particular matrix, for example, if you don't know how to calculate determinant, let me go into the Wikipedia. You can see over here, to calculate the determinant, you have to multiply the diagonals, right? So AD then subtract BC. Okay, so let me just make identity matrix. For example, J equals to np dot identity, and then makes it like 3 rows, and then print j. You can see this is identity matrix. So the determinant of this matrix is 1, obviously, because 1 minus 0, that is 1. So to calculate the determinant, you just need to write np dot len algebra. All are in short form. LIN means linear, and ALG means algebra. So LIN ALG, and then dot determinant, that is DET, and then the matrix which you wanna get. For example, here we wanna get the determinant of J, so we will pass J, and then it will print 1. You can see the output is 1. So yeah, the determinant of this particular matrix is 1. So let me just write over here, this is for determinant of a matrix. And similarly, you can also perform other operations in matrix like inverse matrix and so on, right? You can obviously go into this SciPy link. This is for linear algebra. You can see over here. Let me just copy it and paste it over here, so that you can get it from my GitHub repo. And yeah, so this link is now present over here. You can obviously get this Jupyter notebook, and you can click on this link so that you can perform other operations of matrices. Okay, so now let's perform some statistical operations. So I'll just write over here statistics. Yeah, so for example, let me declare a variable called stats, and that will contain np dot arrange, for example, 6 members, like 2 by 3 matrix. This can be 2 by 3 matrix, so reshape will be 2 by 3. And now if I just print stats, you can see this is a 2 by 3 matrix of 2 rows and 3 columns, obviously. And if you want to know the minimum value or minimum element from this matrix, so np dot mean, and that will show the minimum number from this matrix, that is obviously 0. Similarly, we can also see the maximum number from this matrix. Yeah, it is 5. And you can also play with it, like if you want to get the minimum value from each row. For example, here this is 0 and 3. In that case, we just need to write axis equals to 1, and it will show like in the first row the minimum value is 0, and in the second row the minimum value is 3. And if you make it axis equals to 0, then it will just print the all the members from this particular row, because it will now compare between two columns. So here it will compare between these two columns, these two rows actually. So that means the minimum value of these two rows is 0, and similarly here it is 1 and 2. So yeah, you can see. Okay, one second. Yeah, here you can see that now the values are 0, 1, and 2. And similarly, you can obviously do these things as well over here. So let me just try to it over here. It will be show the maximum row from this particular matrix. So here the maximum row is 3, 4, 5. So it will print this row. So yeah, you can see now if you just make it 1, then it will compare two rows. So the maximum value of this particular row is 2, and then the maximum value of this particular row is 5, so it will print 2 and 5. Yeah, you can see. So you can obviously play with these things. You can obviously sum all the elements of from that matrix. So np dot sum, and then pass the matrix name. So here it is stats, and it will print the sum of all the elements from that particular matrix. And obviously you can also use this axis 0 and axis 1 to get the sum of a particular row and column.